Welcome back, folks. Rational expressions and equations, lesson 5, multiplication of rational expressions. So you need to remember that when we multiply fractions together, okay, which is a rational number, 2 over 3 times 3 over 7, okay, straight across the top, straight across the bottom. That's going to give me 6 over 21. And then I would reduce both of these, divide by 3, divide by 3. That gives me 2 over 7. Something that can be done before you multiply is either top to bottom reduction, just like reducing a fraction, or you can cross reduce. I can reduce this 3 and this 3. If I divide by 3, that's going to give me 1 and 1. That's going to give me 2 times 1 on the top, which is 2, and on the bottom 1 times 7, which is 7. And you can see that in this case, it reduces to the same thing. We get the same answer. Sometimes there might be some further reduction that has to happen, maybe because we miss a factor or something, but remember that that's what can be done, okay? So let's look at example 1. Multiply 7 over 10 times 1 over 5. 7 over 10, straight across the top, straight across the bottom. So you could look for top to bottom reduction first. Neither of those reduce. You could look for cross reduction. 1 and 10 don't reduce, 7 and 5 don't reduce. So in this case, I can only multiply straight across the top, straight across the bottom. That gives me 7 over 50. And I would be complete. Okay. Question B. Again, you could do the one of two processes. I could go straight across the top, straight across the bottom. That's going to give me 45 over 60. And then I would reduce. And maybe you can see it's by 15, but if I see it's by 5, that's going to give me, what the heck is going on? 45 by 5. 45 by 5 is 9. 60 by 5 is 12. And both of those divide by 3. That's going to give me 3 over 4. Or I can look at this and say, hey, you know what? 9 over 10 times 5 over 6. 5 and 10 reduce to 1 and 2. 9 and 6 reduce to 3 and 2. So really now I have 3 over 2 times 1 over 2, which is 3 over 4. I get to the same place by doing my reduction first. Okay? Either or. With rational expressions, step 1, first, we still need to make sure that we state our restrictions. And then we can do whatever reduction necessary, or we can multiply it out and reduce at the end. It depends on what your comfort level is, but this is using your exponent laws. When you're adding, or when you're multiplying with the same base, you add the exponents. And when you're dividing with the same base, you subtract the exponents. Remember from one of our previous units. So my non-permissible value, if they're monomials, again, remember, it's probably just going to be 0. So 4z. So on the side, I'm going to go 4z cannot equal 0. Divide by 4, divide by 4, z cannot equal 0. So that's one way to find it. Or you can just simply say, well, I know that z cannot equal 0. I know that y cannot equal 0. Y cannot equal 0. So there's your non-permissible values, or your restrictions that make the expression undefined, or whatever the other terminology they use. Okay. So now 12a, or not 12a, 2a, 12xy over 4z times 3xz squared all over y. I'm going to do this two ways. I'm going to multiply straight across the top, straight across the bottom, and reduce. So 12 times 3 is 36. X times x is x squared. Y times nothing is not y, is just y. And then z squared. That's my numerator. My denominator for z, y. Now I'm going to reduce top to bottom. 36 and 4, that reduces to 9 over 1, 9, 1. There's no x squared in my denominator, so my x squared stays the same. There's no z in my numerator, so my z stays the same. Oh no, I have z over here. Z squared and z. This z on the bottom will cancel. This squared will reduce by 1, so it's just 1. And then my y squared, or my y's, those will both cancel. So I'm going to be left with 9 over, or no, sorry, 9x squared z. over, oh, everything on the bottom canceled. Everything on the bottom canceled, so don't even need the line. Or I could also do this question or attempt this question by saying, hey, maybe I can do some reduction before I get started. 12 and 4, these are going to reduce to 3 and 1. I can't reduce my x, y, or z in my first term. I can't reduce my x, z squared, or y in my second term, but I can say, hey, you know what? This y and this y are going to cancel. This z is going to cancel with one of these z's, so that 2 disappears. So I'm just going to be left with 9x squared z on my top. I don't need the 1 there, over 1. And that would be complete. Question B. Looks a little bit more complicated. 5a squared b squared c to the 4th over 14b squared cd times 35b over 40a cubed times c. Now, the tough part about reducing as you work through is that sometimes things get lost. So you just have to be very, very careful and write some intermediate steps if you need to. 5 and 14 on my left-hand side don't reduce. A doesn't reduce. B squared and b squared simplifies. Those are going to cancel out. C to the 4th and c, this c is going to cancel. This is going to turn into a 3. Over on the right-hand side, 35 and 40 both divide by 5. So this is going to be 7 over 8. AB cubed, nothing else cancels. So before I get too crazy, I'm not even going to try and do any cross reduction. I'm just going to simplify my numerator. 5 times 7 is 35. A squared, C cubed. Actually, I don't even want the C cubed. Actually, I don't want the C cubed because B comes before C. B, C cubed, all over 14, A cubed, C, D. You can see that my 35 and 14 are both going to divide by 7. That's going to give me 2 and a 5. A squared, A cubed. This is going to disappear. This is going to change to a 1. No B's to reduce. C cubed, C. This is going to disappear. This is going to change to a 2. That's just by using my exponent laws. So this is going to be 5bc squared all over 2. Oh, I forgot the 8. 14 times 8, that's not 14. That's not 14. This is going to be 8 times 14 is 80 plus 32, 112. One, 1, 2. So how does that reduce then? Because it's not going to be by 5. Or actually, it will be by 7. It will be by 7. 112 by 7 is going to be, so this can be 5 still. This is going to be, actually, that's the wrong color. 112 by 7 is going to be 16, I believe. This is going to reduce to 16. So this would change to 16. A, D. There we go. Okay. Example 3. So that was all just monomials. Okay. We can also use binomials. In binomials, we're going to factor and we're going to figure out what can cancel, what can't cancel. Again, when we expand and simplify, we're never going to expand and simplify the denominator. We're always just going to leave it. Okay? It's the numerator that we want to worry about. So here are my non-permissible values. I got to go back to purple. Non-permissible values here. X cannot equal 2. X cannot equal -3. X cannot equal 0. X cannot equal -1. And I would write those somewhere, right? Now, if I'm multiplying, I can cancel factors. This x plus 1, the whole factor is going to cancel with this x plus 1. This x plus 3 is going to cancel with this x plus 3. What does that leave me? That leaves me 2 in my numerator, x in my denominator, and x minus 2 in my denominator. Question B. Here you can see we have some simple factoring that we have to do to begin with. 4x plus 16 is going to factor to 4 and x plus 4. 14x minus 7 is going to factor to 7, 2x minus 1 times 2x minus 1. And I'm going to throw that in a bracket because I want to treat that as a factor. And I'm also going to not expand, but I'm going to write this the way it should be, x plus 4 times x plus 4. When I go to do my canceling, it's going to be easier for me to have this written out like this so that I don't forget it. That's a common error, is if we try to reduce this, we lose it completely. Okay, so I try to do this step. Now I'm going to figure out my non-permissible values. A couple of these are easy. This is -4, this is +4. Oh no, they're both -4. So that's -4, so x cannot equal -4. But this one here is going to cause a little bit of extra work. 2x minus 1 cannot equal 0. Add 1, 2x cannot equal 1. Divide by 2, x cannot equal 1 over 2. There's my other one. So 2 non-permissible values. Now I can do some canceling. This x plus 4, this x plus 4, this 2x minus 1, this 2x minus 1. That's going to leave me with 4 in my numerator, 7 times x plus 4 in my denominator. That would be complete. Over the page. Over the page takes us to example 4. Well, lots of factoring that needs to be done here, right? 2m cubed minus 4m squared divided by 3m squared minus 9m times or multiplied by m squared minus m minus 6 over m squared minus 4. Lots of factoring that's going to happen before we even get started. Factoring my numerator, this is going to be 2m squared, m minus 2. Factoring my denominator, 3m bracket m minus 3. My other side here, two numbers that multiply to -6 add to -1, m minus 3, m plus 2. Over here, difference of squares, m plus 2, m minus 3. Whew. Nope, not 3, 2. Difference of squares, 2. My restrictions or my non-permissible values here, m cannot equal 0, here m cannot equal 3, here m cannot equal -2, here m cannot equal 2. So I'm going to write down m cannot equal 0, 3, plus or minus 2. Okay, m cannot equal, m cannot equal. You could actually write that as one thing, m cannot equal 0, plus or minus 2, and 3, either or, okay? That or these. Now that I have my non-permissibles done, now I can do some canceling. Well, what's going to cancel? Switch colors, let's go to red. M minus 2, m minus 2 will cancel. M minus 3, m minus 3 will cancel. M plus 2, m plus 2 will cancel. This m will cancel with one of these. That's going to leave me with, oops, wrong color, 2m all over 3. Cool. Now, example 5. I would strongly suggest that you pause this video and you attempt example number 5. You can see that the numerator here, this is going to factor by inspection. This is going to factor, I'm going to factor out a -a to do the negative trick, and then there's going to be difference of squares in the inside. This is going to have a greatest common factor of 3, and then it's going to have factor by decomposition. This is a straight up factor by decomposition. I'm not going to work through all of those factoring steps. I'll factor them all on the side, and then I'll start the video again. But you should be able to factor all of those questions now fairly quickly. The whole idea of that entire factoring unit beforehand was to be able to manage this unit. Okay, so somewhere you're going to do your factoring. Like I said, I'm going to factor all of these off to the side, and then I'll come back with the question written out with all its individual factors, and we'll go through the canceling and the non-permissible value step. Okay, so I'm going to pause my video right now, and it's going to come back real quick. But if you're going to take some time, pause your video also and see where you can get to. Okay, welcome back. So our questions factor 2. A squared plus 8a plus 15 factors to a plus 3, a plus 5. 6a squared plus 21a plus 9 factors to 3 times 2a plus 1, a plus 3. A minus 4a cubed factors to negative a, to a plus 1, to a minus 1. And 2a squared plus 9a minus 5 is 2a minus 1 and a plus 5. Okay, and all of that factoring work's done over here. So you could follow those steps if you need to see how those got factored. Okay, now this is multiplication, so I can simply start to cancel. Okay, remember 2 brackets side by side here. That means multiplication. So really those brackets don't even exist. Okay, so I'm going to say, well, this a plus 3 will cancel with this a plus 3. This a plus 5. This a plus 5 will cancel with this a plus 5. 2a plus 1 will cancel with 2a plus 1. 2a minus 1 will cancel with 2a minus 1. And we are simply left with minus a over 3. Negative a over 3. And this question would be complete. Okay, so lots of work, lots of intermediate work over here. Okay, lots of factoring stuff that needs to be done prior to working through these questions. Oh, I know what I forgot though. I forgot non-permissible values. Non-permissible values, which is going to be a little bit hard to see now because I've scribbled on everything. A plus 3 is going to be negative 3. A cannot equal negative 3. This is going to be negative 5. 2a minus 1 is going to be 1 over 2. And 2a plus 1 is going to be negative 1 over 2. There's your non-permissible values. My apologies, I forgot to do that. Okay, but again, we have to make sure that we do that with these questions. That takes us to the end of lesson 5. Short video, shorter than the rest anyway, in recent times. So I'm pretty sure you're happy about that. Checking Stellantis to see what questions need to be done, and we will see you next time.